it's Kermit the Frog. I just want to say I love math. Shout out Mr. Ying.
Hey everybody, let's go over the CVA Integrated Math 3 Quiz number 1, taken September 9, 2022, random sampling statistical experiments analyzing population data. Question number 1, identify whether the sample population is random or biased, polling any teacher's 5th hour about what kind of pizza they like. So random means fair, and biased means unfair or pushes you to lean towards one thing. Well, this one says any teacher with 5th hour or 5th period, there it is, 5th period, about what kind of pizza they like. Well, am I only selecting certain teachers, like males or females, or only teachers with the, last name A, or older teachers versus younger teachers? And in this sample, you'll notice that, well, let me change my colors here. It is a random sample because I can ask any teacher. Question number 2, determine whether the sample population is random or biased. Surveying the 15 people in line for a water slide. So here's my water slide. And these people are already in line. Then you're asking what their favorite ride is at the water park. Well, most likely they're already in line for that ride because they like that ride and probably may even be their favorite ride. So this one is biased. This one's a little bit unfair. Number 3, identify which type of random sampling is used for the population. The first 50 people entering the zoo are asked if they support an increase in taxes to zoo expansion. So I wanted to underline it's the first 50 people into the zoo. Well, the first 50 people is really easy for me because maybe I just want to ask them, right? And then get into the zoo myself if they support increasing taxes. So a quick definition, clustering sample, is if I took all the schools in the district, Savannah, then CVA, and then say Magnolia High School, and I just pick one whole school, right? That would be a cluster sampling. And I don't pick CVA or Magnolia. The answer is a convenience sampling because it's really convenient for me just to ask the first 50 people in line. Random sampling would have been, let's say I got some people in line here. And let's say I would have taken every third person. So every third person, 3, 6, 9, counted by threes. That's called systematic sampling. Systematic sampling. To make it fair, it would have been random sampling. Number 4, identify which type of random sampling is used for the population. There's a key word. Every 15th soup can coming off an assembly line is checked for defects. So I'm circling every 15th. That is a system of sampling, systematic sampling. Question number 5, a researcher who wanted to determine the benefits of using a new algebra study technique obtained a permission from the school district to select 50 high school students. The researcher selected 50 algebra students at random. Okay, they're picked at random. The researcher selected 25 of these students to participate in the new study group. The researcher gave training sessions using the traditional study techniques to the other 25 students and asked them to use these methods. The most likely target population in this study is, well, let's say the first 25 are given the new study program. And here in blue, the second type is given the traditional. So 25 are going to the traditional, 25 is new. This is called an experiment. They're breaking them up in 2 groups, and they're doing something to each of these groups. So this one, the question is asking most likely the target population. Who is the target population? Who are we trying to reach? Well, not all the algebra students in this study. Because the statistics, it's going from small to big. Because this is, if I chose just the 50 students, that's not just like, I'm trying to think of something bigger. That's what the point of statistics is, going from small to big. The answer is all the algebra students in the district. I want to talk about those 50, so that helps me make decisions for all the algebra students in the district. Number 6, according to the American Dental Association, 16 out of 20 dentists recommend using an electric toothbrush instead of the standard toothbrushes. If you create a simulation using a spinner provided below, shade the number of sections that would represent the electric toothbrushes. Okay, let me change my pen color here. And 16 out of 20 dentists. That means 16 out of 20 dentists tell you, yeah, use it, plus the 4 that don't recommend it. So 16 plus 4 gives you 20, so 16 out of 20 are saying use it. You can change that to a decimal or percent. And then 4 out of 20 are saying no, we don't recommend, don't use it. So you can do 16 over 20. And here we have 5 sections. You can make the proportions here. You can just reduce. So you can just divide by 2 here. And you'll get 8 out of 10. And if you divide by 2 again, we're just reducing the fraction here, you get 4 out of 5. So if I shade 4 out of 5 of these, 1, 2, 3, 4. 4 out of the 5 shaded represents 80%. 16 out of 20 is 80%. So if the spinner lands on that section, that is a no section, that would be 1 out of 5, 20%. If it lands on the colored sections, that would be a yes, the dentist does recommend it. And again, you can always just change that to a decimal and recognize that the recommendation is 80%. 80% times 5 sections. Total sections is 4 sections shaded. Number 7, which data set would you expect to have the lowest standard deviation? Remember the conceptual understanding of standard deviation is that when you have numbers, you can do it by numbers, but conceptually standard deviation is a measure of spread. It's a measure of spread. Now the lowest, meaning little spread, like the butter and jam we've talked about, that means it's further away from the center. Further away from the center. Most of the data is further away from the center. Now this example B is a lot of the data is in the center, so that one has low spread. There's a center and these have high spread, or high standard deviation because it's spread out. B has low. C has high spread because a lot of data is towards the left and to the right, nothing in the middle. And same thing for D. So our answer is B. Now you can use this into a calculator. Put in my graphing calculator here. I'm going to press edit. I put in all my numbers into the list. And what I did here is, 18 means I have 3 of those, and I just that's called the frequency. So L1 is the number, L2 I put in the frequency or count, or how many of those numbers. There are 2 number 19s, or 2 X's at 19. So here that means, 21 has 1, 22, 23 has 1, 22 had 0, make sure to add a 0 there. 26 has 1, 27, there's 127, and there's 128. And then you can just go to calculate here. One variable statistics, the nice thing it tells you is where is the list of the numbers and then the frequency, the formula there for 1 bar stats, the very first one there. Again, this is using my graphing calc on my graphing calculator. When I click on 1 var stats here, I have list 1, comma, list 2. So I press second 1, second 2, then enter. And then I'm looking for the population deviation, which is the sigma x 3.629, right above the n. And then there I just wrote, well, that was choice D. And then I did the population standard deviation for all of those, and you're just picking the lowest one. Question number 8, describe the distribution in the histogram which displays the light output in lumens of various sources. So you can put the blob above this. It's a histogram. We talked about the skewing or skiing, and there's nothing to the right. So this one is right skewed. Skewed right. So that would be choices A, B, and C. And now we have to look at the measure of center. The measure of center is kind of like a balancing point, like on a scale or a tipping point. Maybe this is like an iceberg, so how can I balance it? I'm going to have to move it, not exactly in the middle, but maybe somewhere closer, maybe like right there. If I did on the far left there, it would tip. So I think that's this. Tipping point A is your answer, around 600 lumens. 200, it would tip. And if you had 1,000 lumens, it would also tip the other way. So we want a balancing point right there. And those are skewed left, which it's not. All right, question number 9. Each of these data sets has a mean of 20. So they're already telling you the answer here. And now, order the sets from greatest standard deviation to least. So again, they're already telling you, doesn't matter, there's 5 number lists here. Alright, I went to Desmos graphing calculator, and set 1, I'm calling it X as my variable. Capital X equals bracket, list all the numbers with commas, close bracket. You've done it correctly if you write X. You see the words X element list. Then I typed in stdevp, and you can get that by keyboard, functions, scroll down, and you have a couple of these right here. The one you want is stdevp, standard deviation of the population. This one is the sample, so you use this one. And when you do that, I did that for X, Y, and Z, or set 3, I need to write that. So you can just click on this, or you can just type out the words. Now I'm going to do capital Z. And there is my standard deviation. So which of these has the greatest? I have 3.03, 0, and 1.41, so the answer would be 3, 1, 2 is your answer. Now, I did also put a dot plot in there, so you can just type in the words dot plot and then the variable. Dot plot Z. And you have a color here on the side. So I pressed zoom in, so press that, zoom to fit. And then you can turn them off by just making them go away. Does that make sense? So the red one, here's my dot plot. It's pretty spread out. Does that make sense? So it does have quite a bit of spread. And you can just turn it off. Okay, now Y, or set 2, doesn't really have any spread. So if you turn it on, look at, they're all stacked up in the center there, which means there is no spread. That's why the answer for Y, or list 2, is 0. And then if I turn that one off, dot plot 3, see, click on zoom in, there it is. Okay, so it's really spread out, and that's why I have the greatest standard deviation. Alright, so I did question number 10. I'm just using Desmos, capital Y, bracket, enter all your numbers. And you can check out some new YouTube videos coming out soon, how to use the Texas Instrument and Casio if you have those. But Desmos is pretty universal. Separate all your numbers by commas. And we're supposed to find the mean, or average. There you know you have 8 numbers, 9 numbers, 11 numbers, 11. And then close your bracket. And then down here you can just you can type the word mean. And then a capital letter Y, what you got, and your average is 7. And that'll be choices 7. See you later. Bye.
Thou shalt not covet thy neighbor's paper, nor anything that he has. I love math.